Hello, just thought I might make a little update about this pick and place thing. And since I finished my last video, I did a little bit of work on the ScriptPNP, like the client itself. But after that, I've been spending most of my time actually working on the script itself. So not the not the software, but the script for my particular machine to run. So that's what I'm going to be testing here. And my test boards have arrived, so I'm going to be trying to build one of those. Eventually I'd like to build these IO mixers, but they're a little bit complex and dense for what I need at the moment. So I designed this board here, which is rather more simple, and it's going to be 4 of these. So 4 of those are going to be on here. And what this is it's just a little board with some MOSFETs on there, and the purpose of this is to take a 3.3 volt signal and switch these MOSFETs, which can take up to 12 volts was what I was planning on using it for. So it's just a way for a microcontroller to switch a 12 volt load, and that's what I'm using over here. I've got 3 of them. You can see 3 of them stuck on that piece of wood there, and I'm using those to switch these little valves for my vacuum pipes, and they work alright, but as you can see, with them being all separate like that, there's a lot of wiring and it's kind of messy, and we actually don't need 4 MOSFETs on there. I think I designed this to go up to 5 amps, so those MOSFETs can take quite a bit of current. So on here we're going to have just 1 MOSFET for each switch, and we've got 4 basic signal inputs over there. It's just 4 sets of the same thing, and just 1 MOSFET for each, so that's how that's going to go. And I've got one on there in the right place, and I've got some parts just sitting here with some double-sided tapes to make sure they don't move, and this piece of wood is stuck down with some double-sided tape as well. And it took quite a bit of scripting to get this all set up, because what I needed to do was basically create like an instance of each one of these tapes with a whole bunch of parameters, like where's the first tape hole, where's the last tape hole, what is the spacing between each part, or the pitch I think they call it, and then within the pitch, like where's the center of each part, because it's not always the same. See, the MOSFETs are 8mm apart rather than everything else, which is 4mm apart. And then there were some other problems, like this tape being clear was a bit of a pain in the ass. I'm not quite sure what I'm going to do about that yet, but for the time being I'm just using the shiny silver parts of those caps as the identifying location, which is not ideal because, as you can see, they're sort of slightly different positions in each of the holes that they're sitting in. Got some little gate drivers there. That's probably going to be the trickiest piece to place without some bottom vision correction, and these MOSFETs are pretty easy. So let's have a look at what's going on here. The first thing I did was make it so that when I'm setting the fiducials or registering the fiducials, I don't have to manually jog it to each one of them individually. I just need to tell it where the first one is, the bottom left one in this case. So the way I did that was by including in this job table, previously it was just the parts to be placed, but now it has the fiducials as well. You don't need 4 of them, but I try to put 4 on each board if I can. So now in this table we have the X and Y locations of the fiducials. So the script can be a little bit smarter, so that if I place it over the bottom left one like this, then I can just click auto fiducials, and let me just change the thing that we're looking at here. We want to look at fiducial blob. Right, so that's that blob there. So with just one click like this, it will find the first one automatically, and then based on that it'll go to where it expects the other ones to be. Obviously the board needs to be placed approximately at 90 degrees, or roughly aligned the same as the CAD design. So that's that done, and as you can see down here it's done the affine transformation as well. So I can click visit placements now just to check that we're going to go to the right places. A tiny bit off on some of them, but I think it's going to be okay. Alright, so I'll just stop that there. And then for the tapes, let's go over here a little bit. Now we need to look at, I might make this, I find I'm swapping between the same 2 or 3 functions up here quite a lot, so it'd be nice to maybe make this like a pull down list or something like that. But anyway, so based on one of these sliders here, we have 3 different types of tape hole detection. So for a black tape with the MDF behind it, we're basing it on this pink color of the MDF like that, and depending on where I've got this slider, it's choosing the type of HSV thresholding to use. So when I put it here, we're looking at one of these, and so I still need to, for each one of these tapes, I need to come down to the bottom here and go through this procedure. So it's actually a little bit more awkward than that, because currently I have to change a value here. So for this one that we're doing, which is the MOSFET, we need to set this global string value. Now I could put a button on here to do that as well, so I could click the button for each part and then click the tape hole 0, which is what I'm going to click right now. Boom. So it finds tape hole 0, and then we'll go at the top. We should have 12 of these, so then this is going to be tape hole 1 like that. And when we've done that, we can click visit tape parts if we want to just check that this is where the pickups are going to be done from. So that's a bit awkward, but I'm just sort of like finding out where the roughest of the rough edges are and trying to figure out whether this can all be done generically in script the way I'm doing it, which is a bit of a hassle to be honest, or whether it might be worth building into the software itself some concepts like, you know, feeders and tapes and things like that, so that you wouldn't be depending on the users having to write all of their own script to handle that kind of stuff. But anyway, so that's the black tapes, and then we have the, so when I put the slider over to the left, this is the thresholding that's intended for the white tapes. So I've done the same thing for all those, but I had to set this value to be different each time I did it. That's just when you're registering the parts. But now that we've done that, we can click reset job. Reset job will mark every part as not being placed. So in this table here with the job, we have a done column. So after each part is placed, this gets set to 1. And so when I do reset job, it just sets those all back to 0. And the reset tapes button down here, if I click on that, it just resets it so that it thinks that the tapes are all full of parts, instead of, because it's keeping track of which holes have been picked out of already. Oh, and I should also mention there's a couple of tables here that I have called part and tape. And part is just keeping, I'm mostly going with these LCSC part numbers, because I'm probably going to be buying my parts from LCSC. And then we just have the manufacturer part number and a comment, and then which nozzle that part should be using, and the height of it as best I can tell, just from some rough experiments. And then we have a tape table, and this is where I was saying before, each one of these tapes has a different spacing, and then this forward and sideways denotes from the hole that we found how far forward and then to the side we need to go to get to the part itself. And then there's some other things you just sometimes need, like a rotation within the tape, an offset in the case of those larger MOSFETs, when you're not actually picking it up from the center of the part as it's located on the board, because if we try to do that, there's nothing to grab it from. So the center of the part, as we saw, I'm not sure if we saw this before, but when we were looking around the board to check the placements, around about here was where the actual placement in the CAD design is. But if you put the nozzle here, it's not really going to pick it up. So we want to pick it up from here. So that's what this offset X is. This is all a bit rough at the moment. I'm just trying to figure out, because I haven't done any of this stuff ever before, so I'm just learning as I go and figuring out what's going to need to be changed the most. Yeah, so between those two tables, we can figure out where the tapes are located for each of our parts, and the parameters for, you know, the spacing, and how many are left as well is the other thing that we can figure out. So then we have a function called check placement, which I haven't made a button for, but I'll just run it from this here. And this is just going to move the camera to each of the pick locations and then each of the place locations in order. And let me just check. Where is it? So we've got check placement. This load tape functions, that just loads all of the data, or most of the data from these tables here, so that we can refer to it in the script. So it's going to do that every time, but fortunately it's quite fast. And then we just have a query to select which parts we want to place for this job, and I just wanted to check that we don't have a limit on there. So there's no limit on that query, which means we're going to do all of them. And I'll clear this. And at the moment we have the wrong nozzle on, but that doesn't matter. Let me just run this anyway and we'll see what it does. Oh, okay, so part of the script is that we have this concept of memory numbers, which you may remember from my if anybody watched my 2-hour video before, you'll have come across this function called set memory number and get memory number. So this is just a temporary number in memory, and we're using that to keep track of which nozzle is currently on the machine. If it's the wrong one for the part that we're about to place, this script will just stop and it will print this out. So at the moment the user needs to change the nozzle. So the next time I run this script, if I clear this, now that memory number has been set to record that we have nozzle 1 on. So if I run it this time, now as you'll see, that didn't start from the first position in the tape, so I'm going to stop that. I'm going to click reset job and reset tapes. So this time when I run this check placement, it should start from the first location in each tape, like that. So it's just jumping between the pick and the place locations with a 1-second pause at each place. And so I'm not sure if I'll put all of this in the video, but I'm gonna watch through it just to make sure everything is okay. And then after that we'll see about putting some paste on that board and maybe actually doing some placements. By the way, this this clear tape with the capacitors in it, as I mentioned before, I have this other thresholding like this that I used. So I'm actually looking at the solder pads on these caps to figure out where they are, which is not ideal. Anyway, so it looks like all those locations are okay. I'll reset job and reset tapes again, and then when I click place parts on board here, it's actually going to start picking things up and placing them. But I just want to let's go to that function and we will change the clause here a bit. So in this one we're selecting, much of this code here is the same as what we just ran, except that it's actually going to execute the command list, this thing over here, which does the actual picking and placing. So if I go to the end of this, okay, so we've got a limit 4, and we have this clause in here which is going to so we're grouping by parts. So that means we're going to place one of each part and only up to 4. So it's just going to try and place 4 parts. Well, it's actually only going to get to 3 of them because it's going to require me to change the nozzle. But let's just see what that actually looks like. So I'll clear that, and then I'll click this, but I'll show you in the other camera what that looks like. Okay, go. Oops, that's not right. Oh, changing nozzle to 1. It's asking me to change the nozzle. So, yeah, if it doesn't have the right nozzle, which it thought it didn't, but it did have the right one actually, so it's going to bring it towards the front so I can easily change the nozzle if I need to. So that was actually correct. So let me click the button again. Unfortunately, these capacitors, they're not picking at the right location very much. Okay, so it's asking me to change the nozzle again. I'm not going to bother with that because it's just going to pick up the MOSFET. But let's just see how that was placed. Okay, so here's how that turned out. The resistor's probably okay. None of it's particularly great. Wait, was that board set? Okay, so this is not a particularly good result. I've seen better. So that gate driver at the least is going to need a little bit of manual poking to get it in the right place, I think. And then the capacitor is not particularly good either. But I'm okay with that for now. I'm not. It would require some bottom vision to fix this properly, I think. Here's my stencil for putting the paste on. I just stuck it on here with a bit of tape. Hopefully it'll sit in the right place for me, and I'm just going to use this card to squash some solder paste in there. And it's a little bit annoying that if you're only doing a few of these, I think I'm going to have to take this apart to clean it properly, because you don't want to get the paste, don't want to let it dry in these little holes, you know. So I think every time I do this on a separate day, I'll have to set up this, this hinge at least. I'll have to do again each time. And I have a collection of a few solder pastes to try, various temperatures and so on. Seems like 183 degrees seems to be quite a popular or quite a common temperature. So this is my fifth one now, and I realize that you need to stir the solder in the pot quite a lot before you try and get it out. Otherwise it's like there's like flux sitting on the top of it or something. Oh. And that's actually the best one I've done, I think. Not that it's super great. You know how when you get a brand new jar of peanut butter, there's a bunch of oil sitting on the top? That's what this was like a little bit before I stirred it. So this one here, you can see, especially on the left hand side, it's all sloppy there. It's just because it's mostly flux, or there's like too much flux rather. And then this one was the same, and then after I stirred it, I got these ones, which are a little bit better. You can see it, finally there's some separation between those gate driver pins there. And then this one, and then this is the one that I just did, which is not too bad. I'll see if I can get one more that's slightly better than that. Alright, the time has come to click the button. We got some solder paste on this one this time. Go. Oh, changing nozzle to 1. That's alright, we don't need to do that. So let's try this again. Okay. Okay. Looking alright. These are the easy ones. These are just resistors. Oh boy. Oh boy. Not so great there. Why is everything off by a bit? Alright, so now it's asking me to change the nozzle here. Put that one on. Whoop. And now I should be able to just click the button again, and it'll do the other ones. Yeah. Okay, so that's done. And let's move it forwards a little bit so that the light is shining on the board a bit more. And let me lift this camera up for you. And see what we can see here. It's not actually that great, but that's alright. It's the first attempt. Somehow that solder paste got messier just by sitting on the bench for a few minutes. So it looks like all the capacitors and resistors and the MOSFETs will be fine. But as I thought, those gate drivers are not going to be good enough like that, are they? Part of my test that I'm trying to do today is I want to be able to swap another board in and then just push the button again, and it should just all run properly, picking up things from the right position in the tape. So let me take this board off. Alright, so click Auto Fiducials. So it's just going to find those 3 fiducials again. Oh. It didn't find that one. Hang on a second, why didn't it find that one? So the problem I'm having here is that this fiducial there is not sufficiently thresholded to be found. See, the first one, oh, it's only just finding that first one too. So I'm going to have to fiddle with this a little bit. That's really annoying. I don't know why that happens actually. So where's my fiducial? So let me change it to the one where I have my sliders set up. Hey, wait a minute. So hue center is 34. 0 to 255 on the thresholds lower and upper. We'll go with 255 here then, I guess. Is that what you want? Yeah, so something's going to have to be done about this. I think if you can just control the lighting conditions a bit better. Let's try that. Alright, so now if I do auto fiducials again. There we go. Oh no. Now I can't find that one. Alright, so threshold. So this needs to be about 160. But wasn't it 170 before? Oh. Alright, so this one. Yeah, see now this one's starting to lose it. If I make it 190, let's try that. Probably don't need to do this actually, but anyway. So let's find that. Find that, thank you. And now I should be able to find that one as well. Okay, so yes, that is a bit irritating, but now that we've done that, we should just be able to do reset job, because otherwise it's going to think it's finished, right? So I'll click reset job, but I do not want to click reset tapes, otherwise it's going to go and try and pick up from those empty locations. But I should just be able to click place parts on board and should be good to go. Let's see what happens. Oh, changing nozzle to 1, of course. Alright, nozzle is number 1. Ready, go. Oh, you know what I just realized? I just realized I put a board on there that doesn't have any solder paste on it. So I'm going to have to use my tweezers to put these pull these parts back where they were now. Great. You know, the first couple of times I had to put these parts back in the tape, I thought to myself, I really don't want to be doing a whole lot of this in the future. But, sad to say, I have been doing a lot of it. It's very tedious. Yes, I'm going to have to manually set it so that this tape here, it's at the 12th position, that's the next one. I'm going to have to set it to do that manually because I put those parts back in it. That kind of sucks, doesn't it? Okay, so I reset the job and I reset the next index for that tape to be 12, which should pick up the the next one. And we have a board on there that has actual solder paste on it. Let me just see if this is going to work alright. Go. Okay, it looks good. It's dropping them. Oh, it's not actually going down quite far enough, is it? It's sort of spitting them off a little bit. Next nozzle. Nozzle change, there you go. Run. Oh yes, really dropping them from quite a height. I didn't realise that. So one of those resistors was pretty bad. Where is it? That one. Oh, two of them are bad. Yeah, I think my height's not quite adjusted, is it? It needs to press it into the paste rather than just sort of dropping it from above. Somehow I didn't realise that. Anyway. Okay, we should be ready for the last run. This is the last one I'm going to do today. See if I can hold the camera in here. Is that going to help? Maybe not. Anyway. So the mouse is poised over the button on the user interface, so all I should need to do is click here, and so it moved to the position where it wants me to put the nozzle on, but the nozzle is already on, so let's just go. Oh, you know what I should have done? I forgot to adjust the height. What an idiot. This lighting's not great, is it? Alright, well, it's certainly better than doing it all by hand, that's for sure. Wow, some of them are way off. One of the resistors got stuck under the leg of the MOSFET. Oh dear. Alright, I'm sure we'll be able to make something from them still. Okay, I tweaked those positions a little bit, so they should all be perfectly fine now. So I'm going to put it on the hot plate, and I'm just going to manually turn it off and on, keep an eye on the temperature here. It says 183, so I guess we can go to about 200 maybe, should be enough. This SSR, solid state relay, by the way, has already failed. Maybe I was mistreating it by keeping it in its like half on and half off, kind of like in between phase for a long time. But whatever the reason, it's stuck in the on state now, so it's pretty much completely useless. And I really don't like these. So I think if I ever do come back to trying to use the Raspberry Pi to control the temperature ramping a little bit more precisely, or a little bit more autonomously, I'm just going to use a normal mechanical relay. But for today, I'm just going to use this switch to turn it off and on. 170. 180. Wow, almost bang on 183. It's pretty accurate. 198. I better turn it off there. Alright, so I turned it off at 100. I turned it off at 200, which is a little bit later than I was planning on. Looks like everything is reflowed. A couple of those resistors are crooked, but that's alright. I'm just going to have to take it off anyway. So here's how that turned out. The MOSFETs are basically perfect. All of the resistors and capacitors except for that one there are okay. That one's completely off. And the gate drivers are surprisingly good. They look okay from this side. There's one dry pin. Whoops, focus. That one has a pin that looks very dry. And if I turn it around to look at the other side, oh, they might be alright, but I'll touch them up anyway. So let me let me just check that those gate drivers are actually around the right way. I think they are. But if they're not, I should probably stop here before I reflow those other ones as well. Alright, well it looks like everything's working okay there, and the purpose of this board, in case I didn't explain it very well before, is let's say we have a microcontroller over here, but we want to control outputs that are running off 12 volts or something, you know, something like 12 volts. So what I have here is an IO mixer. It's just powered by a power bank there, and it's just turning some of these digital outputs off and on So outputs 1 and 2 are the same as the red and blue LEDs turning off and on just on a timer. And then if you look at the LEDs on the corner there, when I tilt the board, it's using the IMU so that when it goes over 30 degrees in one direction or another, one of those LEDs will come on in pitch or roll, or whatever you want to call that, and the second LED will come on when I tilt it this way. And so those outputs are being taken through these 4 wires there, like that, and then they're just using that to switch the MOSFETs so that this 12 volts will either go through here or it won't. So 2 of them are turning off and on a timer, and then these other two are off until I tilt the board up a little bit. And then one of them will come on that way and the other one will come on that way. So I will be using these to tidy up my vacuum valve switching wiring, which was a huge mess as we saw earlier. I don't need 4 of them, but I might as well, thought I might as well have 4 just in case I need something later on. Anyway, so that's going to do it for this video. Suffice to say that I'm starting to see some limitations or awkwardness in having to do everything by script. It can be done, but whether anyone else would want to do it is the question. I don't mind it for myself personally, but it's starting to look like it would be nice to, instead of trying to keep everything as generic as possible and do it all in script, maybe it will have to include some concepts like, feeders and tapes and all that kind of stuff like I mentioned before. We'll see. We'll see how it goes. Anyway, thanks for watching. See you later.